I'm Jigar Raisinghani, and I'm working as Associate Manager of Software Engineering at Red Hat. I'm primarily working with the sustaining engineering team within Red Hat, and most of the work that we do is related to backporting, where we take patches from the latest streams and we backport it to the previous streams. Today we are going to talk about the need, the business impact, and if there are any ways to automate backportings, and why do we really need to automate backporting. So this is the agenda, and we are going to cover about backporting, why it's required, the business requirements, and understanding different types of backports, and also if it can be automated in some way. So what is backporting? So backporting essentially means that you take a fix or a feature from the latest version of software and you make it available or make it a part of the older stream as well. The reason why we do it, because there are a lot of users and customers who want to stick to the older versions for various reasons, and they want those certain vulnerability fixes on those versions as well, because even they want security for their business needs. So where is it most common? It is most common in kernel space, because if there's any vulnerability or if there's any bug which is present in the previous versions, it can cause a lot of operating system level issues. And also in enterprise systems and LTS versions, a lot of customers who are using it, they really want it. And in the next slide, we'll talk about why they want it. So why is backporting required? It's mostly for security, stability, and hardware support. So a lot of banking customers, defense customers, and a lot of telecom industry, these customers really require vulnerability fixes for a lot of reasons. And also a lot of customers are using older hardwares, and it is not always possible to run the latest software on that versions and on those hardwares, and then it becomes really important that we keep the previous versions very stable, and yes. So what is the business requirement? So for a lot of our customers, enterprise customers, compliance is an issue. They need to have a lot of security to deploy their applications. And also when we talk about migrations, the easiest way or a customer support team would want is that you go to the latest version and everything will be available there. A lot of the patches are available, a lot of issues are fixed there, but then that would mean that as a customer, I need to invest a lot of money in upgrading. And also it would mean that testing your software with the latest versions, and it is a lot of cost. So if a customer can get a fix on the older versions, if we can assure them that your version of the software is equally secure and stable, and we will be providing all those fixes, then they do not have an immediate requirement to go to the latest versions. So it saves a lot of costs, and a lot of customers want stability, and they want to run the same version of the software for longer periods of times, and that is where we provide them the support. So now let's talk about how backporting is actually done and what are the challenges. So most of the backporting that is done is manual. So some of the statistics mention that almost 80% of the patches take almost 20 days to backport, which means that if the fix is available on the latest stream, it takes around 20 days to make it available on the older streams. Almost 50% of the patches take over 46 days. And some of the very difficult backports can take more than a year. Now what it essentially means, that there is a vulnerability out there, everybody knows about it, but the older versions of software does not have a fix, and now there is a delay in backporting, which means that the older versions of softwares are vulnerable, which means the attackers can potentially use that, and a lot of industries can be at risk. When we talk about manual backporting, it can, if a human is involved, there is a potential to make mistakes, and it can cause regressions as well. And there is code drift, like one version of the software can be written in a certain way, there can be refactoring, there can be various ways how the code has changed, and then because of the drift, it becomes very difficult for a human to actually backport the fixes to all the previous versions. And that is one of the challenges we see as a team at Red Hat as well. Now, what are the different types of backporting? So there are five major types. Like first one is when there is no change required to backport, like most of the versions are rebased and the latest fix can easily get backported because there is not much code changes. Second is like patch changes, like the location of the patches are changing, and now you need to figure out like how or where the patch has changed, and then a certain amount of knowledge can be used to actually make the backport. And if there are any variable or function changes, that is another type of backport, because now you need to understand the code and also understand how and why the variables were changed. And then there is a combination of 2 and 3, that is the patch location has changed and also the variable and function names changed. And then the fifth type and the most difficult one is where the logic or the inherent way the software was written or the feature was written has changed. So the last three are the difficult ones because it requires certain domain expertise and also expertise in the way the language works, and certain mastery over the language and domain is required to do those backports. Now let us see, can backporting be automated? So there is one tool that is Fixmorph, which has been around for a while, and what it essentially does is it analyzes the patch's abstract syntax tree and it builds certain rules around it. So supposing if I want to backport one patch to a previous version, so it will convert it into AST. I'll talk about it in the next slide. It will build some flexible rules. For example, like the previous version had the variables name a, b, and say the latest has x, y. So it will try to build flexible rules in saying that x, y could be a, b, or it can have some other variable name in like the previous versions. Then what it does, it aligns the code versions across, like for example, if we talk about RHEL 9, Red Hat Enterprise Linux 9 and 8, so it will try to align those versions, and then it will try to apply those patches and see if it works or not. Now, what is the real impact? So when this tool was actually tested, there was a 75% success rate in kernel patches, which would mean that if I backport 100 kernel patches, like 75% would be done with major accuracy, but 25% would not, because it might fall in the last three categories which I talked about. Like the real impact of backporting with automation is that it handles security and LTS patches, and also the challenge is when doing it with the real world software is that it requires some kind of expertise to actually backport like the most difficult one. So if the tool cannot understand the underlying logic, then it becomes really difficult to use automation. And that is where like a lot of future also lies, because now we are talking a lot about AI and its ability to understand semantics, and it might be able to detect how the code has diverged over a period of time, and maybe like tools like these which provide 75% success right now, with the help of AI, it might be able to do a better job, and that is where the future lies, according to me. Now, in the previous slide, I talked about AST, so it's basically abstract syntax tree, and what it does is like when what it will do is it will take a patch, it will convert it into a certain form where it talks about the code logic, not about like the brackets and commas and everything, and then it will try to compare it with the previous version of the patch or the software, and then using this syntax tree, it becomes easier to actually compare it to the previous versions. And now let's talk about the key takeaways. So why is backporting critical? We saw at various reasons that it is important to keep the system stable and secure. We looked at manual methods. So manual methods can be error prone. They can be slow because it takes a lot of time to do the backportings, and with the help of certain tools like say Fixmorph or maybe in future AI-based tools, we might be able to reduce that time And once that time is reduced, it provides like a faster and secure way to support our customers and a lot of users on the previous versions. And Fixmorph has shown a strong promise in automation, but I would not say that it is a go-to tool for like all the backports, and you cannot rely on it blindly. But then it is at least an attempt to say that backporting can be automated. And yeah, this area is still evolving, and with deeper semantic understanding, like it is the future. And also with like, I would not say AI, but then it's still in the nascent phases. But we are working in Red Hat. We are working in an in-house tool called Patchpal for at least kernel backportings. So it is a little more promising right now, but again, it's still in development, and we started with it like just a few weeks back, and then it's still evolving. So yeah, that was my time. Thank you, everyone. And any questions? Yeah.
How to check that the automated patch is working?
So there is. What? Yeah. So you want to say how do we verify if the backport works or not? Yeah, so backporting essentially means the dev part of the things, like we are taking a patch and then we backport it, but then comes actually the build part where you actually apply those patches and you build the software in whatever, like based on the tool, like there is a build procedure, and after that there is a QA, like you need to test it for regressions, you need to run different kind of test cases, and then if everything passes, then you can say with a certain surety that the backport actually worked.
Okay, so it's relying on the tests that you write for this patch, or
yes.
So the tests are also like backported, or
Depends. Like if they are specific to that particular feature or patch, then yes, you need to do, like for example, if there is a reproducer, then you need to try it on the previous version as well. Yeah. Yep. It is generic. It can be used, but most of the statistics are around kernel right now. But the way it is designed, it is more generic. It can be used for all the applications. Yeah. Yeah. It's based on, so there's a fixed morph. Yeah. So you're talking about the numbers which I showed, like how long it takes to backport. So there is a research paper on fixed morph. I'll just add it to the slides and share the slides. So it shares the statistics that like a lot of patches take a much longer duration to actually backport. Yeah, because for example, if I tell you on say Red Hat Enterprise Linux 8, like it has certain kernel version, but on Red Hat Enterprise Linux 9, it is much ahead. So taking any patch from say the latest version and backporting to RHEL 8 or RHEL 7, it's a huge code difference, and then it can actually take a lot of time to make sure that the patch works on the previous versions as well. Yeah. Any further questions? Or okay, thank you everyone.